The following video will be presented to you by none other than 5 Kilobyte Productions. It's been a while since I've done a presentation of a tape recorder. So this video will be another presentation of a tape recorder. I could say recorder if I so desired, but it's fun to say recorder. Come and, well, Murphy, take a look at this recorder. It is made by Grundig, but you already know that because of the title. It's model TK1, but you already know that because of the title. Let me move this wire out of the way. Anyway, here is the manual. Of course, I have to look on the computer monitor screen. I cannot look at the camcorder screen because, lo and behold, the backlight to the camcorder screen has quit working. Probably, I think it's connection. So it's just blank. So anyway. Tape recorder TK1 Lexus E. A black and white photo of the recorder by Grundig. Take a quick look through this manual. Probably dark as all can possibly be. The light in the room is not the light in the video. The light in the room is aplenty. The light in the video does not reflect the light in the room. I know you'll want to see better pictures. I know you'll want to read the manual. First of all, my camera's not HD. So I can't actually get a good enough video image of the manual to read all the details. And I'm not going to skim over the entire thing with the camera. That's just too much trouble. But it's pretty neat. And there's a list of some specifications. And here is a schematic for how you can go into a radio and make a DIN connector adapter to record onto a tape recorder from it. Samurai Clinton's not going to like this. And here's even the dimensions to make a hole for installing a DIN jack. Printed in Western Germany. So, then we'll show the schematic. Very, very nice to have a schematic. I'll have to put so much brightening on this video that the contrast is going to look terrible, and things that should be dark will look like a gray color. But anyway, there is the schematic. There's the motor control circuit schematic, and they even have well, blurry, put it that way, pinouts for all the transistors. Here is the packet that would house the operating instructions. Pretty basic. Safety. I farted. Probably going to show it going down because it's a slow computer. I already pressed stop. Just to show the case real quick. There's where it says TK1. You can't see it because it's too dark. Maybe that's better. I bet Clydesite would find this recorder to be interesting, and I bet so would the real master. Now let's take off the top cover. here is the interesting specimen of a recorder. Let me inform you that this piece right here, we put it on this surface here, it tells what all the knobs do and everything. It simply, you can take the knobs off and it goes under the knobs. See? Oh yeah, it goes under the knobs right there. I decided to take it off and I just store it up under this thing here. I decided to take that off because it looks pretty cool that way. Now notice, as I do this, I will prop the recorder up at an angle on the back, on that piece there. You'll be listening to the description recording, which is very lengthy, and you'll then be able to understand why I have it at an angle. Without further ado, let's listen to the recording.
Hello there, and welcome to the video of the Grundig TK1, or the Grundig TK1 Lexus, as this one has that name included, although it is simply the Grundig TK1. Reel-to-reel portable tape recorder, which is going to use up to 3-inch reels and runs at 3 3/4 inches per second. It's the only speed it's set to run at. This recorder is AC bias. The amplifier uses 5 transistors. The bias oscillator uses 1 transistor, and the motor speed regulator circuit uses 1 transistor. The bias frequency is approximately 40 kilohertz, and the frequency response of the recorder is from 80 hertz to 10 kilohertz. The recording level indicator is a DM71 tube. The DM71 Magic Eye tube is in the form of an exclamation point, and I think that's pretty funny that it looks like an exclamation point, and it is used for the recording level indicator. For a good level you want it to fluctuate, but the overdriven is shown whenever the exclamation point's line touches the point. So I will give an example of an overdriven recording. What you're hearing now is an overdriven recording. You can hear the effect of tape saturation. This recorder is made in Germany, and it's from 1960. Now, for the story of my quote restoration. I can't consider it fully restored, but it's basically restored to the best of my ability, or at least close to that. I got this machine on eBay, and whenever I got it, it was pretty much dead on arrival. Whenever I put batteries in it to test it, it would barely move for playback, and it was able to rewind. But in both modes, you could hear extremely loud noise of the motor rubbing against a hard rubber surface. It was like kind of sound. The reason being is that the idler wheel, where well, let me describe it. There will be pictures to show it, so you'll be able to see. But what it was on the flywheel, there's a metal plate screwed onto the flywheel, which on it has a rubber O-ring. The rubber O-ring is turned directly by a spindle on the motor shaft, which presses up against the O-ring and drives it in a rim drive fashion. The rubber O-ring was all hardened and cracked and no good. So I had to replace the rubber. So, to get a new O-ring, I went to an Ace Hardware store and I bought a new O-ring. This one was an orange colored ring. It was not a circle in its cross-sectional way. It was actually rectangular cross-sectionally. It was made for drains, as specified at Ace Hardware. It was it said drain repair or something like that on it. So it's made for drainage pipes. But this O-ring was the right diameter and thickness to replace it. So I used epoxy glue and glued it into place, and that was quite a successful undertaking. And the motor shaft gets good traction and runs it well. But now for the other parts of the story. Well, of course, the amplifier had plenty of leaky electrolytics. This machine probably hadn't been used in quite a number of years, and it probably was not stored in the best climate, judging from the condition of the rubber and the numerous leaky capacitors, and also the condition of the motor. Perhaps, maybe. I don't know if the environment affected the motor or not. It might have. So I replaced 10 electrolytic capacitors, which I was very quickly and easily able to identify thanks to the homemade ESR meter. It would have been a lot harder to find out which capacitors were bad if it weren't for the ESR meter. So, then on to the motor. The motor was not in the best shape, and it was quite weak. When it received full voltage and unregulated for the rewind function, it performed well. But from the regulator circuitry and to try to regulate the motor speed, it did not perform well at all and was very weak and hard to keep a constant speed. So it had a very hard time turning the drive system, at least at the full 3 4 speed. And plus, when holding the recorder at certain angles, or which would hold the motor at certain angles, the motor would squeak. It would whine. Because it was worn out or something. I don't know if that's from the brushes or what, but the motor wasn't performing that well. So I had a hard time with the motor. I tried replacing the transistor in the motor drive circuit, thinking, oh, maybe the transistor's just weak and the motor's fine. But it still had the same problem. So I thought, well, I'll try building a whole nother circuit. So I found a circuit online which uses a 741 op amp and a transistor to pass the current. And it is a motor speed regulator circuit. I had built it a while back as a test and with the motor, and it seemed to work well. So I decided I would want to build the circuit again and test it with this motor and see if I can regulate it using that circuit. The original circuit couldn't regulate it. But in the testing stage, the motor performed exactly the same and was not able to be regulated at all. I was able to adjust the speed from the circuit I had built, but the regulation was not there. So I didn't permanently build the circuit, and I resorted to using the replaced transistor that I had put into the original circuit. So, further improved a little bit, maybe through use. And now I found out that I can, if the machine is held up at a slight angle, of course it has to be the back of the recorder has to be up, not the front. Or if it's operating vertically, the motor will seem to be regulated pretty well. Maybe not as good as it should, but the motor seems to actually have some regulation, which was not there before. So the motor seems to be operating pretty good whenever it's operating at a slight angle, but whenever I operate the machine at a horizontal, just fully horizontal, you hear a little bit of squeaking from the motor, and the speed is not regulated well at all, and it's just very unstable. That's very disappointing, but at least I can operate it properly whenever it's running at an angle. So it seems the motor itself has seen better days. So I know this is a very long recording. It was super long recording. But instead of describing all this in the video and then showing recording, I might as well describe it on the recording. Although I'll still be showing recording later in the video, so I can demonstrate the I-tube in operation. But I-tube runs at 90 volts. By the way, the bias oscillator circuitry has several windings on the several secondary windings on the transformer for the bias oscillator, and one of them feeds the I-tube with the 90 volts, which I think that's pretty cool. Anyway, back to other things here. So the motor's weak. Oh yeah, and also, just last night, I was running it on the fiber belt that runs the take-up reel finally gave way, so the take-up stopped working. So in order to fix that, I got a piece of string and wrapped it through there and tied the string, and now I just hope the knot that I tied doesn't come untied, because if it does, I'm not going to have a good time. I didn't put an actual belt on there, because seeing where I'd have to take the plate off where the capstan and head are mounted would be way too much of a hassle with the way some other things are mounted in that same place, and I was like, no, that's going to be way too much of a hassle to try to get that mess off, so I'm just going to wrap a string through it. So now the take-up drive works again. But still there's some problems I'm having with the amplifier. When I turn the volume at maximum during playback, it tends to squawk and squeal and make all sorts of annoying noises. And it's only whenever it's...
You can hear that miraculously it is not doing that right now. Although if I were to plug in the microphone, you'll hear a congratulatory squeal. Not feedback, by the way. This is not microphone feedback. You can adjust the extremity of the squeal by adjusting the volume. And the frequency somewhat, too. Not good.
Up towards the maximum volume. And
weird thing, it only does it with this microphone. I do it with a different microphone or with a line level connection through there. It doesn't do it.
And then it used to not do that at times. Actually, it did that basically a lot more than it didn't do it. But there were those times whenever I was able to run it all the way with it not doing that, but that's very rare. And then sometimes it would do this other kind of distortion where it's like a very low frequency that was being pumped through, so it was like... I'm not sure exactly what's causing that. I suppose that I might just need to reseat all the transistors, because the transistors are mounted in sockets, and it's possible that the connections to the transistors in the socket aren't very good after sitting for so long and oxidation and stuff. I might just have to reseat the transistors and clean the pins with WD-40. I haven't tried doing that yet, kind of a hassle to take the circuit board off. Again, I'd rather not have to mess around with that if I can avoid it. But anyway, I'm hoping that won't be hard to fix, because that is very annoying how the amplifier does that. I will be demonstrating that also in the video. It's a very strange phenomenon. If anyone knows exactly what would be causing those kind of issues, if it's not having to receive transistors, what is it? Oh yeah, side note, I already sprayed the record play switch like 3 times or something like that, so I don't think it's the record play switch. By the way, the microphone I'm using for this recording is not original to the machine. I'm missing the original mic, but I'm using another microphone that is made by Grundig that goes to another recorder, and I can say this microphone is very good quality. Anyway, although this recorder isn't running as good as I wish it would, it's still a pretty nice recorder, and I hope you enjoy the rest of the video. Sorry this recording is so long.
You could hear towards the end of the tape, the wow and flutter was unbelievable. That's not from the motor. Let's just rewind a little bit. Let's run it with the volume all the way down so we can hear the sound of the motor operate. Okay, maybe it is a motor slightly, I don't know. But the reason why it's doing that is the tape to head contact tension, or the pressure for the tape to head contact, is supplied from back tension on the supply reel. There's a foam pad that goes against and provides friction, so it does not turn with extreme ease like most portable reels do. It does not have any foam pads to press the tape up against the head, as a lot of portables do. This one uses back tension. But the drive isn't very strong, so when you get towards the end of the tape, it gets a smaller diameter, smaller radius where the tape is on the reel, and it makes it harder to pull. And when it makes it harder to pull, it makes it harder for the drive to take it up at a steady speed, so the wow and flutter just starts going haywire, and it's not that bad whenever there's a lot of tape on the reel. I think at some point I'm going to have to try to adjust the tension. There is a way to adjust how much that foam pad is pushing, a felt pad is pushing against the supply reel for the tension. But the adjusted screw is sideways and it's kind of down in there, and it's not really easy to adjust. But I might have to try to get to it anyway and adjust it, because I don't want that flutter there. It's very undesirable. So you can hear when it rewinds, the motor's running quite well in rewind. And it's nice and fast because the regulator circuit is bypassed. So it runs at the full 6 volts. Motor runs at 6 volts. Amplifier runs at 9 volts. How they do it is they have 6 batteries. It has 4 Ds and 2 Cs. The 4 Ds run the motor. Then those same 4 Ds are put in series with the 2 Cs to give 9 volts, and that supplies the amplifier. Interesting design. I want to demonstrate recording. Before that, I will show how it records music, because I recorded some music from YouTube. It's by Autumn, one of my favorite electronic music bands. I might have to put the name on the video later. I don't remember fully what it's called, but you can hear how this records music. Oh yeah, I remember now. It's called Not Afraid to Die.
Would you tell me politicians I don't have to lie. Why have to fight? Why
You notice that? When I turn that reel, the tape to head contact is lost, and the audio goes away. Oh, it slipped on the pinch roller, I think.
No, here I go.
So that's the tone control. Interesting thing about the tone control, whenever you're in record mode, the tone control turns into a volume control for the recording monitor. The level control is still by the regular volume control in the middle, but the tone control provides, if it's all the way down, it's no volume, and if it's all the way up, you get a little bit of volume out of the speaker to monitor what you're recording, so I think that's pretty cool. By the way, it's a single, well, technically a two-head unit. It has a record play head, but then the erase head is just a permanent magnet that swings over onto the tape.
Won't you please tell me why I don't have to lie?
But as you can hear, the audio quality itself is very good. So if I can get all the flutter issues worked out, and especially if the motor will start to work horizontal. The motor is working very close to horizontal. The angle doesn't have to be very much, but once it gets horizontal, it starts doing good. If it will start working at horizontal, that would be good. And if I can get that flutter issue fixed, that would be fabulous. Because you can hear the recording quality is just very good. And I like that a lot. The machine has no fast forward. To fast forward, you have to do this.
Of the Grundig.
So what I'm going to do is I'm going to demonstrate recording now. To go into record, you have to hold down this safety interlock. You can't just move the knob over. You have to hold down that while moving the knob. That's so you can prevent accidental erasure. Luckily, you can still do that with one hand. Put your index finger there and then just move the knob like that. So now it's in record mode. When it's in record mode and it's not receiving a signal, you can see the eye tube is lit, and it's lit to that set point right there. Looks like a little exclamation. Now we're going to plug in our microphone. DIN, of course. 3-pin DIN. You cannot use a 5-pin DIN plug. It's a very nice thing to be able to have all these. I have several DIN microphones now, and several DIN jack cords and stuff. I used to not have any DIN jack stuff, being that I'm in the United States. It's already quite a situation to be able to even find this machine on eBay in the U.S. Because in the U.S. you don't find very many European vintage tape recorders as opposed to Japanese vintage tape recorders, which are the most popular. At least when it comes to portables, there are more Japanese recorders than there are American recorders. That's the irony. I have 4 American-made reel-to-reel portables and quite a few Japanese-made portable reel-to-reels. And then a few European. Actually, I have more European recorders than I have American-made recorders. And just because something says RCA on it doesn't mean it's made in America. I have an RCA reel-to-reel tape recorder that's made by Iowa, not RCA. I have another RCA which is made by Sanyo, not RCA. It's funny because it says like for replacing parts or something, like only use genuine RCA parts. It's like, really? Seriously? It's got Sanyo parts in it, or maybe one's got some Toshiba transistors and stuff. So there's a lot of dishonesty with the brands, which I find annoying. I like it whenever a company makes the recorder that the company and that whatever company makes the recorder, it's that company's brand name is put on. I don't like it whenever they have one company, but then they just slap another brand name on it. That's like, that's outright lying. That's lying. If it's a Sanyo recorder, don't call it a RCA. It's a Sanyo. If RCA wants to make a recorder or make their own recorder, don't ask someone else to make it and then just put their brand name on it. Anyway, enough ranting about that. Let's show how this records. So this is a Grundig recorder. It's made by Grundig, although I will say that not all the parts are Grundig, but it's another thing if just some of the parts aren't the brand. It's another thing if the entire machine is made by another company. Because the bias oscillator coil in here is made by Siemens. But that's not a problem. That's not what I'm ranting about. What I'm ranting about is when there's an entire machine, say, made by Iowa, but then it's the RCA says, let's slap RCA on it and pretend it's made by Radio Corporation of America, when it's not. Anyway, let's show how the iTube works. I did a lot of ranting right there. But anyway, if a machine is in Iowa, then it should be in Iowa. Of course, I have Iowa machines, but that RCA should be labeled Iowa, not RCA. Anyway, you can see here how the iTube works. The length of the line of the exclamation point extends as a stronger signal is present, and whenever the line touches the point, or about touches the point, it is overdriving, which I will demonstrate. That's the feedback. I'm now overdriving. You can see the point gets more extreme and exaggerated. You can even see the point part of it actually expands. Now our regular recording level, again, you can see how that is. So I can show recording like this, and it should make a good recording at this level. I will now be setting the microphone down, setting the level up, and recording at a distance. Stop it. Microphone, set it right there. Set the level all the way up. Turn the recording control, the monitor down. I'm now recording at a distance, not that much of a distance, but it basically will show how it can pick up sound. This actually can pick up sound quite well while recording. So anyway, let's see how this sounds. Let's stop the recording.
Second. It's the only speed it's set to run at.
It's not doing the squeal as bad as it did before. Definitely an improvement. Well, actually, that's because I had the tone control down. It's more extreme when the tone control's up. Which is very strange. Now let's rewind. So now I kind of feel free to just go on in my videos because I'm not restricted by the 15-minute time limit. So it's already over 30 minutes long. That basically means if you want to watch this video, you got to really want to watch it because it's going to be long.
Hello there, and welcome to the video of the Grundig, so I can show recording like this, and it should make a good recording at this level. I will now be setting the microphone down, setting the level up, and recording at a distance. I'm now recording at a distance, not that much of a distance, but it basically will show how it can pick up sound. This actually can pick up sound quite well while recording. So anyway, let's see how this sounds. Stop the recording. Second.
Very nice. Again, I'll show. You hear how the motor squeaks more whenever it's at a horizontal line. You hear how it runs slower.
and welcome to the video of the Grundig. So I can show a recording like this, and I should make a good recording at this level. I will now.
So anyway, you got to see how the recorder operated there, how it sounded. You can see now how the recorder looks without any reels on it. Let me put this at an angle again. That's basically the normal operation for this recorder in its condition. So anyway, pretty cool. It's got little things you turn to like that, so the reel, things you turn like this so the reel can be held on. On this one of the three things is broken off, but the two still hold the reel on fine. Cosmetic issue is this metal piece is missing. If anyone has a spare, I'd appreciate one. But anyway, now what I'd like to do is compare it with its cousin. The cousin to the TK1, and probably the one that came first on the line of the recorders of this style, is the Grundig Nikki. I already made a video of it, but I'd like to show a direct comparison in this video. You can see it. It's more whiter in color. This one's more yellowed. I think it's supposed. It might be supposed to be that kind of more yellowed color. At least the plastic, I think it's supposed to be that color. This one's a lot wider, and this machine is made in 1961, but it came out in 1959. The original 1959 model, from looking up things on the internet, had a metal speaker grill and was DC bias. This slightly later version of the Grundig Nikki has a plastic speaker grill, so you think, oh, now they're using plastic and not metal. But they did improve it. Don't worry, they did improve it. This one's AC bias, not DC bias. This one uses a, I think it uses a 4-transistor amplifier, and then it uses a 1-transistor bias oscillator. I already made a full presentation video of the Nikki. You can see here I put this piece back on. This one's stop button does not lock down. But if you didn't see the video of the Nikki, I'll give you a quick rundown on the Nikki. The Nikki is basically a more basic version of this one. If I remember correctly, the Grundig Nikki's frequency response goes up to 6,000 Hertz. I think it's from 120 Hertz to 6,000, or 100 Hertz to 6,000, something like that. But I remember it goes up to 6,000 Hertz, I think. Whereas this one, again, goes up to 10,000 Hertz. So this one is a lot better frequency response. This one also uses a permanent magnet to erase. And it has a record playback head. It also uses back tension to provide tape-to-head contact, as opposed to a foam pad pushing up against the head. But this one, the biggest difference between these two units is that this one is rim drive, whereas this one is capstan drive. So this one will run at approximately 3 3/4, depending on where you're at on the reel. I think at about somewhere in the middle of the reel, somewhere in there, you'll be running it around 3 3/4. You start a little bit lower at the beginning, a little faster at the end. Of course, that's the nature of rim drive. But this rim drive, if you didn't see the last video, has a lot more. It's built a lot more beefy, you could say, than a typical cheaper rim drive recorder, like many of the old rim drives you see, with the very cheap designs and 4-transistor DC bias. You know, a lot of the rim drive recorders that you see have a very weak take-up drive and tend to have wow and flutter issues. Not this one. This one's take-up drive is very strong. It actually has a flywheel inside, a belt-driven flywheel. Then the flywheel part pushes against the rim of the rubber on this take-up reel, and the rubber is very good quality rubber. And this one's drive is so strong that it actually has a stable speed. Not a constant speed, but a stable speed. There's a difference between the two. This one doesn't have issues with wow and flutter at all. And it's such a nice strong take-up drive that this back tension does not cause any wow and flutter issues like it does on this capstan driven machine here. So there's a little bit of noise from interference from the motor, but other than that, it's working great. This one, it actually moves the reel tables when operating. This one does not move the reel tables, they stay in one position. So I'll give you a quick showing of this one's recording quality before the video will be ended.
Okay, I'm now recording with the Grundig Nikki. This one does not have any way to tell how strong the recording signal is. It does not have any level indicators. You just have to use how loud you're speaking and the position of the volume control to tell. But anyway, this is an example of recording on the Grundig Nikki and how it sounds. You can hear, although it doesn't sound as good, it still sounds not bad. Also, take note that I'm now using a Philips microphone, one that goes to that one with the reels on top, the reel with the reels on top. The reason why is because the Grundig microphone that I used with the TK1 does not cooperate with the Nikki. It's very strange. It records in a it sounds very strange on the recording, and it even affects playback with adding distortion whenever the jack is plugged in. So that Grundig microphone is kind of weird with some recorders, well, with this recorder, and it also, of course, likes to make the TK1 squeal. So anyway, but I have to use the Philips or some other microphone with this recorder. Anyway, you'll hear how this recorder sounds, how the microphone has to be different, etc. Anyway, hope you enjoyed hearing the Grundig Nikki's recording.
Basically restored to the best of my ability, or at least close to that. I got this machine on eBay, and whenever I got it, it was pretty much...
Also take note that in rewind on the Nikki, the motor speed regulator circuit is still in operation, so the rewind is pretty slow. You can see they have the same kind of layout of the coloring of these parts here that it switches to. So the layout of the recorders is very similar. This was a ridiculously long video. I hope you enjoyed this video on these recorders. Bye bye. As you know, I had to get more rubber. Here's some pictures. Here's the rubber roller, the new one, glue drying. Here's a close-up showing the rubber on the flywheel plate, not the actual flywheel. Here's the old rubber. The old messed up, deteriorated, bad rubber. Not really deteriorated, but here's the flywheel itself. You see the motor shaft. Another shot showing the inside of the flywheel itself. There's a shot of the back of the circuit board to the Grundig TK1. And here's a shot showing the circuit board with the original capacitors. Here's another shot showing. And yet another one of the circuit board with original capacitors. Here you can see a close-up of the bias oscillator transformer. Here you can see the new rubber ring put on the flywheel. Here's a picture of the circuit board by itself with original capacitors. A close-up showing the AC bias section of the circuit. Another close-up. Another picture and with the original capacitors. Here is it after I replaced the bad capacitors. Another picture after I replaced the bad ones. Here's a picture of the top of the machine with the cover taken off. A closer shot, you can see the capstan and pinch roller. Underside showing some of the circuitry. This is after I put the string in, I think. Yeah, that's when I had the string. I had to put string in for the take-up reel drive. There's a picture of the eye tube. Looks like an exclamation. Picture of the speaker. This is for Speaker Freak 95 to see. I'm sure he will enjoy seeing the speaker, especially how it goes down a little deep like that. Another shot of the speaker. Really nice little speaker. It's a square magnet too. Here's a picture of the exclamation when it's recording. Another picture while it's recording. Another while it's recording in different light settings. Another picture while it's recording. A good shot of the exclamation point. Another picture while it's rewinding. You can see the reel spinning. Oh well, that's the end for the video. Yep, and here's the ending cassette master production. Anyway, I hope you enjoyed this video.